So yesterday we used Pascal's triangle to do some binomial expansion. We are going to talk about the binomial theorem today, which is still a way that you can do it, but it's also a way you can just find a single term within it and not have to write the whole thing out every time. So here's part of Pascal's triangle again. And what this first thing tells us is that each element of Pascal's triangle is assigned a row n and an element r number. So the numbers in the triangle, they are the actual elements. Remember, we start counting with the rows at 0. So this is row 0, 1, 2, 3, 4, 5. The elements also start at 0. So this is element r, element 0, element 1, 2, 3, 4, and 5. Okay? So the fifth term, 1, 2, 3, 4, 5, is actually the fourth element. So the term number and the element number are a little bit different. We've got to make sure we can keep all that stuff straight. So the nth row, rth element of Pascal's triangle, is denoted as this. This is one time where it's not missing a fraction bar. Usually when you see something like that, it's when my fraction bar has disappeared. It's not a fraction, okay? That's how you do combinations, something you should have seen in geometry when you did combinations and permutations. You may not have seen it this way. You may have only seen it this way, but either way, they mean the same thing, and we'll look at both of those. And then here's our formula, n factorial. What is fact? Because that doesn't mean n, like you're excited. What does a little exclamation point mean for n? Like what would we do if I had 5 factorial? Yep, exactly. So let's make a little note of that up here. So your factorial is exclamation point, right? So if I have 5 factorial, again, it's not an excited 5. It is 5 times 4 times 3 times 2 times 1. That's how you would find 5 factorial. Okay. All right. And these are, the C is for combination, P would be for permutation. So it would be n things taken r at a time, kind of like when picking the basketball team on that video we watched yesterday. How many different 5-player teams could you make? That's kind of what we're looking for here. But that helps us find the actual elements in here. So if we're going to find the 6th row, third element, then that means the 6 is the n, right? This is equal to n, and this is equal to r. So when we write this out, it's going to be 6, 3, which is the same thing as 6C3. Okay, those are like little subscripts, 6's and 3's. And that would be equal to 6 factorial over 3 factorial times 6 minus 3 factorial, which is really just 6 factorial over 3 factorial times 3 factorial. Now, here's the good news about these. We're doing this by hand because we're gonna do it by hand and we're gonna do it on the calculator because you need to understand both and how they work. I don't have to actually multiply out 6 times 5 times 4 times 3 times 2 times 1. I can make the numerator match the biggest factorial in the denominator. They're both 3, so I think I'll make it match 3. So if I start writing this out, this is 6 times 5 times 4 times 3 factorial, right? And divide that by 3 factorial times 3 times 2 times 1. Do you understand how I started writing this out and then I can just stop because that means the rest of it? So then this 3 factorial cancels out with this 3 factorial. 2 times 3 is 6, cancels out with 6. I'm left with 5 times 4. My answer is 20. So the 6th row, third element, is 20. And then I have to write out the whole thing. We good with that? All right, let's look at we're going to jump to number 3. So 18th row, second element, this is going to be 18 taken 2 at a time. So that's the same thing as 18C2, which is 18 factorial over 2 factorial, 16 factorial. Everybody understand where all the numbers came from? All right, so when I start to write this out, I'm going to make this 18, I'm going to make the numerator part match that 16. So I'll have 18 times 17 times 16 factorial over 2 times 1 times 16 factorial. So then I can cancel out the 16 factorials. 18 divided by 2 is 9. So then I just have 9 times 17. Which is 153. Okay. Questions about that? All right, so let's look at number 4. Number 4, I'm going to have 25 taken 14 at a time. So that's 25 C14. So that'll be 25 factorial over 14 factorial times what? 11 factorial. Okay, so we're not going to do that one by hand. That would still be a lot of numbers to do. We're going to do things 2 different ways on the calculator. So the first way, we got to know where factorial is. When you type this in, you have to put a multiplication sign between those two in the denominator. So if you look at your calculator, right below the mode key in yellow, you see the excited X there? There's your factorial. So hit your fraction key and do 25 factorial in the numerator, and then the denominator 14 factorial times 11 factorial. And you should get 4, 4, 5, 7, 4, 0, 0. Okay. Any questions? We find factorial on there, we're good? Okay, so there's reasons you need to know how to find factorial on there, but the calculator also has this on here, where you don't even have to type this stuff out. So if you look at the division key, right above it in gold, you see the NCR? So on this calculator, what you have to do, we're going to type in 25, then you do shift divide to get the C, and then 14. And the numbers aren't little. You just put them before and after, and it still does the same thing. Hit equals, there's your answer. You see that you get the same thing. Okay, we good on that? All right, so let's go up and do number 3 like that then. So it's still the 13th row, 5th, oh, why am I making a fraction? I already said it's 5th element. That's equal to 13 C5 do it that way with your calculator. Make sure everybody can figure that out. And the Desmos calculator does have, if you do the Desmos scientific calculator, it has the NCR button on there as well. What you should get here is 1287. So make sure you actually get that so you know you can type it in and you know what you're doing. Everybody good? Any questions at all? All right. So let's look at how we're going to use this. What this gives us is the elements in Pascal's triangle. It doesn't actually give us any terms in a binomial yet because we haven't applied it to that. So that's what we're going to do here. So the r plus 1th term in a binomial expansion of a plus b to the n power is defined as this here. Okay? Now remember, the r, the term number, and the element number are different. So if I'm looking at the 8th term, and this is the r, that means it's the r plus 1th term. So r plus 1 is 8, which means the term number r is actually 7. Okay? So it's the 8th term, but it's the 7th element. And then n is equal to 10 because it's the exponent. So that means I'm going to do the 10(7) here times a to the n minus r power, 10 minus 7 power, times b to the r power. So in this case, since a and b are both variables, all you have to do in your calculator is this part. So if you type that in, what do you get? $120. So you'll have 120 a cubed. Oh, why did I put b to r? R is 7. I could have put 7 there. Sorry. B to the 7th. So remember to find your r, that's equal to the term number minus 1, because r is the element number. We okay with that? All right. What is, so on number 6, what is n? 7. What is r? 3. Very good. So I'm going to have 7 things taken 3 at a time. Then I'll have 3a to the n minus r power to the 4th power times negative 2 to the 3rd power. And notice my exponents still add to give me 7. Adds to give me n, just like it did before. So this time when you're done, you're going to have, you only have one variable, so you'll have a to the 4th. Once you get this number in your calculator from the combination, you're going to have to multiply it by 3 to the 4th and negative 2 to the 3rd. Let's go ahead and multiply that out, see what you get. That's what you should get, so make sure you can get that so that you know you're doing it correctly. Now, if you don't handle the negative correctly there, it's not going to make a difference because it's an odd exponent. But remember that there's a difference between negative 2 squared and negative 2 squared. Those are not the same thing. This is going to give you negative 4. This is going to give you a positive 4. So if you don't know how to handle the numbers in the calculator, that could be a problem in any calculator. We good? What questions you got? Okay. All right. So on the back here, I know this looks very intimidating, but it's really not as bad as it looks. They just have to have a generic for a binomial expansion. Can't even get the words out of my mouth here. So it could be that I have 37 terms. It could be that I just have 4 terms, whatever. But this is how it sets up to make it actually work. So the first, whatever n is, your first little combination is going to be n things taken 0 at a time. So if I have 5 things and I take 0 groups, there's only one way to do that. So that's always going to equal 1. 0 factorial also equals 1. We'll talk about why a little bit later. But then the next thing I have is n things taken 1 at a time. Well, if I have 5 things taken 1 at a time, that's going to give me 5 different groups. And then from then on, you'd have to actually type them. Oh, not 5. I'm sorry. It's n. I was using 5 as an example. Whatever n is. So when you add them all up, that is your sum. What does this weird-looking symbol mean? Sigma. And that's all an equation is you're just adding up the terms. You can't. So we're going to expand this binomial. We did this yesterday with Pascal's triangle, but we don't have to have the triangle written out because it works this way too. We could just find one term. We could find them all. So this is what this is going to look like. Since n is equal to 6 here, we're going to start with 6 things taken 0 at a time times a to the 6 times 2 to the 0 power. So just like what we did yesterday, the exponents will always add to give you whatever n is. Then I just go up by 1 each time here. So then it'll be 6 things taken 1 at a time times a to the 5th, 2 to the 1st, plus 6 things taken 2 at a time, a to the 4th, 2 to the 2nd, plus 6 things taken 3 at a time, a cubed, 2 cubed. Okay. So you keep going without me saying them out loud. So that looks like a lot of combinations that you have to type in, but 3 of them you're not ever going to have to type in to do the crazy combination, because this one is going to equal 1 every single time. This will always equal n, which is 6, And then the last one, 6 things taken 6 at a time, there's only one way to do that. So you don't have to actually type those in that way. So if we start cleaning this up with the first term, I know this is going to give me 1, this is going to give me 1, so I just have a to the 6th. And then I'm going to mark it out so I know I already used that term. Plus, then I'm going to have 6 times 2, which is going to be 12, a to the 5th. Mark that one out. Plus, then you're going to do 6c2 times 2 squared, and that'll be your coefficient for the next one. So you go ahead and do that one, see what you get. Should get 60 a to the 4th. And go ahead and keep on going. Did you find it on yours? Any questions on how to get any of these? All right. So if you've gotten a few but you haven't finished, just go ahead and write them down and you know what you're doing at least. Got them all. Okay, so let's look at number 8. So here n equals 5. So I'm going to start off with 5 things taken 0 at a time, 3n to the 5th, 4 to the 0. Plus, then this becomes 5, 1. Then I have 3n to the 4th, 4 to the 1st. Go ahead and see if you can write the rest of that out. Just follow the pattern. Once you start to clean it up, remember this is going to equal 1, this is going to equal 5, and this is going to equal 1. So that kind of minimizes what you actually have to type in. Any question on how to get this filled in? All right, then I'm going to write out what the answer is. You make sure you can get these numbers. Any questions on how to get any of these numbers? We're all good? We're getting the right ones? All right, if you got at least the first four, then you just write down the last two. It means you can get them. Alrighty. Let's look at this last one. N is equal to 4. So I'm going to have 4 things taken 0 at a time times 5 over x to the 4th, y to the 0. Plus 4 things taken 1 at a time times 5 over x to the 3rd power, y to the 1st, and so on. So here there's just 2 combinations that you would have to actually type in. So this first term, this would be 1, this is 1. So this is going to give me 5 to the 4th over x to the 4th. So that's 625 over x to the 4th. And here I'd have 4 times 5 to the 3rd, which is going to give me 500. I'm going to have a y in the numerator and x cubed in the denominator. You finish up the rest of that. Once you're done, double check yourself with me, then let me know if you have any questions.